So this question, you can see that it is asked about the Lineweaver-Burke plot. It is also called as the double reciprocal plot. So this question is from enzyme catalysis, very important topic, enzyme catalysis. Now, it is also, I told it is also, this Lineweaver-Burke plot, it is also called as double reciprocal plot. Why it is called as double reciprocal plot is because it is plotted between 1 by V and also 1 by S0. So since it is, this mechanism is also called as the Michaelis Menten mechanism. Now let us see what is happening in the reaction. I will be explaining a bit more to make the concept clear. So it may appear that the problem is a bit lengthy. No, it is not a lengthy problem, but once you understand the concept, it will become very easy to it. So don't jump into some shortcuts in the initial days. Just go through the actual mechanism and study it. So if we go to the Linman mechanism, it is like the enzyme plus substrate gives you the enzyme substrate complex, and it is like a quasi equilibrium. So this is a rate constant is forward rate constant is k1, and this can be reversible also, so that your reversible rate constant is k inverse 1. Now in the second step, the enzyme substrate will be decomposing with a rate constant of k2 to give you the enzyme free enzyme plus the products. So as we know, this is the our rate determining step, RDS. So that your rate can be written as rate is equal to K2 into concentration of ES. So now your task is to determine the ES, the enzyme substrate complex. As we know, we cannot determine the exact concentration of ES. You have to apply the steady state approximation SCSA for the determination of ES. So two assumptions are made here. One is steady state approximation, and another one is the total enzyme concentration E0 at any time will be equal to concentration of the free enzyme E plus the concentration of the combined enzyme, which is E substrate complex. So taking both of these aspects and making some manipulations in the equation, your rate will be equal to, of course there will be K2, and the concentration of ES will be given as E0 multiplied by S, and here in the denominator you will be having Km plus S, where Km is called as the Michaelis Menten constant. It is just the ratio of K inverse 1 plus K2 by K1. So always be reminded that whenever you see a rate equation of this sort, the numerator will be, the terms in the numerator will be enhancing the rate. They will be enhancing the rate, whereas the terms in the denominator will be decreasing the rate. They will be decreasing the rate. Now, so our rate equation we have got as rate is equal to K2 into E0 into S by Km plus S. Now, what will be the maximum rate of this equation? For the rate or the velocity, let us denote it as V, since in your question it is related as V. V is equal to K2 into, I am rewriting this equation, into S divided by Km plus S. So what will be the maximum rate? The maximum rate can be denoted as Vmax. That maximum rate will be equal to K2 into E0. What does that mean? Whenever the free enzyme, the total all the enzyme is used, or at the initial state, all the enzyme will be free, that is the E0. At that time you will be having the maximum rate, that is K2 into E0. So you can substitute that one. So V will be equal to Vmax into concentration of ES divided by Km plus S. Now let us take the reciprocal of this equation. So this will be 1 by V will be equal to Km plus S divided by Vmax into S. So if you rearrange this equation will be, this will be Km by Vmax into 1 by S plus S by Vmax into S, or this can be written as Km by Vmax into 1 by S plus 1 by Vmax. Now you see this equation, what we have to do is we have to plot 1 by V versus 1 by V versus 1 by S. That is why this is called as a double reciprocal plot. Now here you can see that this is just equation of a straight line. Y is equal to mx plus c, and your slope is km by Vmax, and your intercept is 1 by Vmax. So now let us see the option. You can see all the four options, and you can easily find that your right answer is option number 1.